Today we're going to start chapter 2 and we're going to work on section 1, which is analyzing conditional statements. So this is going to get a little bit confusing at first, and once you learn the format and you learn the definitions and stuff like that, it gets much easier. But at the beginning, it is a little bit challenging, so be patient with yourselves to learn this stuff, okay? So conditional statements basically have two parts, okay? They have the hypothesis part, and then they have the conclusion part. We identify the hypothesis part with the P, the letter P, for example, and then the conclusion, we label it with a Q, just so we don't have to write hypothesis and conclusion, or so, it's just a shortcut kind of. Conditional statements can be written as if-then statements. So, for example, if you study, then you will get an A. So, if P, then Q. Okay, and how we write this using symbols is this little thing. We do P and then an arrow to Q. So if P, then Q. Sometimes we're going to negate a statement, okay? And what that means is it's the opposite of the original statement. So in other words, if the original statement says it is raining, a negation is where we say it's not raining, okay? If the original statement says that the shirt is not red, then the negation is that the shirt is red, okay? So if it says something is something, a negation says it's not. If the original statement says it's not something, the negation says it is. So now we're going to go from the original conditional statement to some alternatives or some variations of it. The first one is the converse. Okay, so a converse is formed by changing the order of the hypothesis and the conclusion. In other words, what we're doing is we're swapping the P and the Q. So in the original statement, it says, if you study, then you will get an A. So if you study is your P, right? Then you will get an A. You will get an A is your Q part, right? So if P, then Q. The converse of it basically says that if you get an A, then you studied. So if Q, then P. So that looks like this. If Q, then P. So what you did is you just switched the order. An inverse is a little bit different, okay? An inverse is formed by negating both the hypothesis and the conclusion. Remember, we already talked about what negating was. So when we're talking about an inverse, if the original statement says, if you study, then you will get an A. If P, then Q. This is your Q part, right? Remember, we got P, then Q, okay? The new one's going to say, if you didn't study, because that's negating it, right? Then you didn't get an A. And how we write a negation is, if not P, then not Q. And so the little squiggly line is the negation part of it, okay? So if you didn't study, then you didn't get an A. So again, the order from the original is still the same. It's just you added the negation part of it. The third kind of little twist we're going to have on this is what we call a contrapositive. Now, the contrapositive is when you take the original statement and you basically do both the converse and the inverse to it. In other words, you take the original statement, you switch the order, right? You put the Q before the P, and then on top of that, you negate both. So a contrapositive, let's say the original one is, if you study, then you will get an A. This is your Q, right? So right now you're at P and Q, right? The converse of that would change the order. So it would be, again, if Q, then P. And the contrapositive, now that we switch the order, is going to negate. So if you didn't get an A, then you didn't study. And so if not Q, then not P. And so again, I know that's weird, but it's basically the contrapositive is basically the converse and inverse applied to the original statement. So it is both. Lastly, we get to what we call biconditional statements. And a biconditional statement, what happens is if we do a conditional statement, our original conditional statement, right? If the original statement is true, and if the converse of that original statement is true, having such a hard time highlighting here. If the converse is also true, okay, then the statement can be written as a biconditional. So, and we like biconditionals because biconditionals are really what definitions are made out of, okay? A definition can really, of anything, can be written as a biconditional. And once we know that something is true in both directions, in other words, if something is true, if P then Q, and then if Q then P is also a true statement, then it's a biconditional. And what we do is we add this if and only if statement to that, okay? So basically, any definition in math and in geometry, or even in the real world, any definition can be written as a biconditional statement. And when you practice it a little bit, you get really good at it. So, for example, here we have an original statement. The original statement says, if an angle has a measure of 90 degrees, that's the P, then it is a right angle. That's the Q. So if 90, then a right angle. And we know that this is a true statement. So now we want to see if the converse is also true. So the converse would be if an angle, right, is a right angle, if Q, then it must have 90 degrees. And notice that that works too. If it's a right angle, then it has a measure of 90 degrees. That's also true. And so this would lend itself to being able to be spoken as a biconditional statement. So in other words, we would say P if IFF Q. And so you're like, well, what does that mean, right? So let me show you what this shortcut is. We would say P if and only if Q. Okay, that's where this if and only if part comes in. So remember, in the original problem, P was an angle has a measure of 90 degrees. So this would say an angle has a measure of 90 degrees if and only if it is a right angle. Okay, and so that's how we do these biconditionals, and that's how we say it. Whatever was P, we say first. Whatever was Q, we say it second. And in between, we do the if and only if. So we don't have to do if and then statements here. We can just do this IFF as a shortcut. So if and only if, when we're writing it as a symbol or when we're doing a shortcut, we do IFF like that. And that's kind of how we represent these biconditionals. I'm coming back to this slide to add something to it. Another way to show this one I forgot is a double-sided arrow, because basically what that says is if P then Q, if Q then P, and so the two-sided arrow is another way to do this. So let's just kind of look at the symbols one more time, and then we're going to do some, okay? So again, consider the conditional statement before. And a conditional statement, again, remember, that's a basic if-then statement, okay? In other words, you know, something is conditional upon something else. It's like, if this is true, then whatever's going to be true or happen, okay? So that's where the if-then is what makes it conditional. So in words, if I do a regular conditional, if P then Q, then I write it with these symbols, P then Q, okay? Remember, the converse is where we swap the P and the Q. So if Q, then P, and again, Q then P is the symbol. The inverse keeps the original order, it just negates it. So it's now if not P, then not Q, and again, that's how we write it. The contrapositive is actually the converse and the inverse combined. So we take the original conditional, we switch the order, and we negate it. So if not Q, then not P. Okay? And a biconditional is where we are lucky, where the original and its converse are both true. And if that happens, then we can write it as a biconditional, and we would say P if and only if Q, They also do the 2 arrows. I forgot about that on the last slide. So I'm going to go back and add that. And then, or you can do this, okay? The IFF, same thing. That's in words. So now let's do some problems and actually put it into play. And the more you do, the more you'll kind of get used to these, okay? Use red to identify the hypothesis. So red to identify the hypothesis, and use blue to identify the conclusion, okay? Then write the conditional statement in if-then form. So all birds have feathers, okay? So again, now we got to switch this into a hypothesis and a conclusion and an if-then, right? So I would say if it is a bird, then it has feathers, right? And so my hypothesis is if it's a bird, if it's a bird, then it has feathers, okay? If P, then Q, or PQ, right? So if it's a bird, then it has feathers. Now we go to B, and we're going to do the same thing with B. B says you are in Texas if you are in Houston. Now here, notice that they actually gave you a statement that had if. It was just written after. It's okay. It doesn't always have to be written in the proper order, right? So this one here is really saying if you are in Houston, right, then you are in Texas, okay? And so again, you notice that the if part or the hypothesis is if you're in Houston, and the conclusion is then you're in Texas, okay? So, your P and your Q are there. So when you look at it, okay, it does take a little bit to see what's the if and what's the then, and sometimes you're not really sure which would come first or not. Sometimes they make it very obvious where the if statement is, and sometimes it's not so obvious. Okay, so now they tell us what the P is and what the Q is. In other words, they're telling us that if the P is your hypothesis, if you are a guitar player, then you are a musician. There's the Q part, right? So if P, then Q. So it says, write each statement in words, then decide whether it is true or false. So the first statement wants you to write the conditional statement, P, then Q. So that's just expanding it out. If you are a guitar player, right, then you are a musician. A musician. And you know what? We have to decide if that's true or false. And that's true. If you're a guitar player, then you are a musician. So this one happens to be true. And again, you can kind of color, code here's your hypothesis, and here is your conclusion. So that one's A. When you go to B, they want you to write for B the converse of it. In other words, if Q, then P. So here we would write, if you are a musician, that's the Q part, then you are a guitar player, because that's the P part. And so again, right, now what happened was we swapped our places. Our P became our Q, and our Q became our P, right? And so what happens now is let's ask ourselves, is this true? If you're a musician, then you're a guitar player? Well, that's not true. You can be a musician and be a drummer. You can be a musician and play the trumpet. And so this one, the converse, actually ended up being false, because when we switched the order, the statement was no longer true. When we go to the inverse, which is C, it says, remember that the inverse keeps the original order, it just negates it. So we're going to write it, and so instead of if you are a guitar player, the negative or the negation of that would be if you are not a guitar player, right? Then you are not a musician. And so now again, you're like, wait a second, let me think if this is true. First, let me make sure that I did this right? My original was if you are a guitar player, so the negation is if you're not a guitar player. The original conclusion the conclusion was you are a musician, which here the negation would be you're not a musician. So if you're not a guitar player, then you are not a musician. Well, that is also false, because I could not be a guitar player, but I could be a drummer. And if I'm a drummer, I am a musician. And so this is false. So the inverse of this is what I wrote in C, and it's a false statement. Okay? And then we go back to the last one, which is our contrapositive. And remember, the contrapositive is really the combination of B and C. The contrapositive swaps the order. It basically puts Q first and then P, and then it negates Q and P. So when I write this out, it's if you are not a musician, that's negating the Q, right? Then you are not a guitar player. And so again, this is how we write it, right? The first thing I'm going to ask you to do is just write it, okay? Now we're going to analyze if that's true or false. So if I am not a musician, then I am not a guitar player. And that's true, because if I'm not a musician, I'm not any instrument player, right? I don't play any instruments, so this would be a true statement. And so notice here that, they want you to do two different things here. They want you to rewrite it in words, which is what we did here, and then the true, false, false, and true, or, whatever, figure it out if it's true or false. Now, remember we talked about the biconditional, the if and only if statement? In a biconditional, I know they didn't talk about it here, but to be able to do an if and only if, the conditional statement and the converse must both be true for that to be able to be written as a biconditional. Here, because the converse is false, this would not lend itself to being written as a biconditional. So I want to make sure you understand, not everything can be written as a biconditional. This certainly cannot. Okay, so here we go. Rewrite the definition of perpendicular lines as a single biconditional statement. So notice this is a definition. Definitions can always be written as biconditionals. Right now, our hypothesis is if two lines intersect to form a right angle, and our conclusion is then they are perpendicular lines. So again, to be able to do this as a biconditional, it has to be true in this order, P then Q. And if you notice, if two lines intersect to form a right angle, they are perpendicular. That is true. And if I switch it and I do the other order, if I say, if they're perpendicular lines, then the two lines intersect to form a right angle, that is also true. And because both of those are true, I can rewrite this as a biconditional. When I rewrite my biconditional, it doesn't matter which one of these statements I put first, okay? I always put the original P first, but it doesn't have to be. So it would be two lines intersect to form a right angle if and only if they are perpendicular lines. Okay, notice if and only if here. And notice one thing, I know I didn't put the if and the then in the final biconditional, because a biconditional statement actually does not have the if then in it. Okay, so I could have written it like that, and I could also have written it as I could say two lines are perpendicular lines if and only if, and I could use that as well. They intersect to form a right angle. Sorry about so sloppy here. Okay, so I could have put the blue first. Okay, so here I have the blue. Oh man, sorry. Here, in the first one, I put the blue second. In this one, I put the blue first. In this one, in the first one, I put the blue first. Here, I put it second. Notice either way is fine. I could do either one as long as I have the if and only if in the middle. And again, notice that none of them have the if or then in them, okay? They just have the if and only if part that I added in there. And if I was to write it in symbols, I would have just done this. So much easier in symbols. Lastly, it says rewrite the pair of conditionals as a biconditional. So again, now I'm giving, these are math things that they're giving me. So I notice here, if M is between L and N, then LM plus MN equals LN. So this is, if you guys remember, if M is between, point L, whoops, it's a segment, point L and point N, then we know that LM plus MN equals the whole thing. And so this is really here the segment addition postulate, okay? And then notice that, so this is where they told me the segment addition postulate, and they made the hypothesis, this part here, if M is between L and N, then the sum, whoops. So F is between the 2 points, then the sum equals to Ln. And then they did, notice that's the original conditional, and then they did the converse of it. They said if Lm plus Mn equals Ln, then M is between L and N. And so what they did was they took the original here, this is the original statement, and then the other one is the converse, okay? And we see that both the converse and the original is true. And because they're both true, I can write it as a biconditional. So I would take that first statement, without the if part of it, obviously, and without the then part of it, and I would just say M is between L and N, if and only if Lm plus Mn equals Ln. Okay, so again, in here, you're going to notice I took the original, oh my gosh, sorry guys. I took the original hypothesis part, I took the original conclusion, and I took off the if and the then, and I replaced it in the middle with if and only if. And once again, I could have done in the other order. In other words, I could have done Lm plus Mn equals Ln if and only if M is between L and N. And so again, what I did here, a little bit different, is I put the original conclusion part first, I put the original P second, and again, I separated them with if and only if. In a biconditional, since it is the same whether it's the original conditional or the converse of it, I can write it with P or Q in any order. I could, do it with P and Q, or I could do Q and P. Okay, so this is kind of an interesting fact. I usually do, no matter what, I usually do P first in my biconditionals. But again, it could be either way. All right, and so that's the gist of this lesson. And guys, it just takes a little bit of focus on memorizing the different parts to it, okay? Again, you're going to want the conditional statement. That's going to be, let me do it in black. The original conditional, if P, then Q. You're going to do the converse, which you're going to switch the order, if Q, then P. When you go to inverse, you're going to do the original order, except it's negated. So if not P, then not Q. You're going to do your contrapositive, okay? And that one is both the converse and the inverse. So it's going to be not Q, then not P. And then your biconditional is going to be P with the double arrow to Q. And again, the more you practice this, the better you're going to get. This is one of those things. If you don't do these a lot, they're going to all jumble together. Okay? We will go over this more in class.